Welcome to mathematics classes. Today we'll see video 6 actually, sixth video for applications of differentiations. These are the critical questions which are important for your class 11th, 12th, JEE, BITSAT and other engineering entrance exams. Let's get into the problems. Okay. First one, for f of x equal to sin x plus 3x minus 2 by pi into x square plus x, where x is in 0 to pi by 2 inclusive, which of the following statements are true? Okay, f is increasing in 0 to pi by 2 and f dash is decreasing in 0 to pi by 2. So this is a simple question. Only thing is you need to validate two statements here. Okay. We know that how to find out if a function is increasing or decreasing. You just take the derivation of that function and check if it is increasing or decreasing. Based on that you can tell. Correct. So this is my f of x. Okay. This is my f dash x. Sin x differentiation is cos x. 3x is 3 minus 2 by pi x square plus x differentiation is 2x plus 1, which is, if I simplify, this is what it is. Okay. Now f dash x is increasing or decreasing depends on whether this expression is positive or negative. Okay, always greater than 0 or always less than 0. If you see here 2 by pi, okay, 2 by pi is fractional part between 0 and 1. Okay, because 2 and this pi is 3.14, so denominator is bigger than numerator, so this is fractional part between 0 and 1. Okay, less than 1. Okay, so minus 2 by pi is minus some small value, then minus 4x by pi. Okay, minus 4x by pi, what is the maximum value of this one it can go? Okay, the range is 0 to pi by 2, x range is 0 to pi by 2. So if I take pi by 2 here, this is maximum 2. Correct. So 2 minus less than 1 value, sum of these two will be obviously less than 3. Okay, so this is positive. This expression is positive. Correct. And in 0 to pi by 2, cos x also positive, which means this whole expression cos x plus this whole f dash x is positive. Correct. If this is positive, that means in 0 to pi by 2, which means the function f of x also is increasing function in 0 to pi by 2. Okay. So statement 1 is true. Exactly same way we will do the statement 2. Okay. You take f dash x and do second differentiation, that is f double dash x, which is nothing but minus sin x minus 4 by pi. Okay, now we know that this is negative. This is a constant term, this is negative, and sin x is minus sin x is negative in 0 to pi by 2, which means this whole expression f double dash x is negative, which means f dash x is decreasing function in 0 to pi by 2. Okay, so statement 2 also correct. So the answer is both S1 and S2 both are true. Okay, hope you understand this problem. This is a simple applications of differentiation problem, finding increasing or decreasing of a given function. Okay, next. Okay, f of x equal to determinant of the given expression here, where x is a real number and then what is the value of 2 f of 0 plus f dash 0 is equal to. Okay, which means I need to find f of x and f dash x. Only then I can substitute x equal to 0 and get the answer. Okay. So how to do this? First one is simple. F of 0 is simple. I just need to substitute x equal to 0. Correct. Instead of expanding that this determinant, I just substitute x equal to 0 and see wherever in the determinant also I put x equal to 0. I get a simple, very simple determinant. Okay. So now this is very easy to calculate, right? So I can do it by the first column because there are two zeros. So minus 2 into minus 2 minus 4, okay, which is basically f of 0 is 12. This is very simple. Now how to get f dash 0? Okay, for f dash 0 I need f dash x, correct? So how do you get f dash x? So you need to find out full expression, simplify it and then find out f dash x, correct? So there is other way. If the function is given in determinant form, okay, of a matrix form, matrix determinant form, then you can do f dash x by doing row wise and summing up. Okay, so example, f dash x of this given determinant is nothing but differentiation of first row. Okay, x cube differentiation is 3x square, 2x square plus 1 is 4x, 1 plus 3x differentiation is 3, and other two rows you write as it is, plus you do now second row differentiation and other two rows you keep original. Okay, plus third row differentiation and keep the first and second rows original. Okay, now this is what is the f dash x. This you should know. Okay, if a function is given in determinant form, this is how you can do very easily. Okay, now you substitute f dash 0 x equal to 0, you substitute, then it will become f dash 0. Now this is simple determinants, right? These are all simple determinants which you can easily find out. So the answer is 18. Okay, now f dash 0 is 18. So what they asked is 2 f of 0 plus f dash 0, which is nothing but 2 into 12 plus 18, that is 42. This is the answer. Okay, next. If the local maximum of function f of x equal to square root of 3e divided by 2 sin x whole to the power of sin square x, okay, where x belongs to 0 to pi by 2 is k by e, then what is the value of this k by e whole to the power of 8 plus k to the power of 8 by e to the power of 5 plus k to the power of 8? Okay, so whenever you see f of x to the power of g of x, how do you do differentiation? By taking log, correct? So you need to take log here also. F of x is this, so log of f of x is sin square x into log of square root of 3e divided by 2 sin x. Okay, now if I differentiate this, okay, I get f dash x by f of x, which is equal to 2 sin x cos x, that is for sin square x, and then into second g of x as is I wrote, plus sin square x as is I wrote, and then differentiation of log of this one. So this is 1 by this value, which is nothing but 2 sin x by square root of 3e, okay, into minus square root of 3e by 2. Okay, that is 1 by sin x differentiation, basically, that is cosecant x. So uh, cosecant x into cot x. This will become minus cosecant x. So, okay, minus cosecant x into cos x. Okay, so now simplify this one. Okay, so my f dash x is nothing but f of x will go to other side. So that is this value, and I can take sin 2x common from this expression. Correct. So sin 2x into this one. Now this is equal to 0. To find the local maximum, I need to equate f dash x equal to 0, right? To 0. So this is 0. Now we know that this is always non-zero. Okay, f of x whole to the power of g of x is always non-zero, because here this base is not 0, never 0, and this is never 0. Okay, sin 2x sin 2x is not 0 because 0 is not inclusive. Okay, 0 is not inclusive, pi by 2 also not inclusive, so sin 2x is never 0. So only thing which can be 0 is this value. Okay, so now you equate that to 0. Okay, then if you simplify, what you will get is take half other side. If you remove the log, it will become e to the power of half, which is nothing but square root of e. So square root of 3e by 2 sin x equal to square root of e, or simplify further, you will get sin x equal to root 3 by 2. Okay, and we know x is between 0 to pi, so only one value we have. Okay, anyway, correct. So maximum value of this one is square root of 3e by 3 whole to the power of 3 by 4. Okay, because f of x I am substituting here actually. Square root of 3e by square root of 3, because this is 2 sin x, right? 2 sin x is nothing but square root of 3 whole to the power of 3 by 4, square of sin square x, right? So 3 by 4. So this is nothing but e to the power of 3 by 8, which is equal to k by e. Okay, so now you just need to put it in the k by e form. That's it. Okay, so k is nothing but e to the power of 11 by 8. So once I know this one, the given expression k by e whole to the power of 8 plus k to the power of 8 by e to the power of 5 plus k to the power of 8 is nothing but e to the power of 11 by e to the power of 8 plus e to the power of 11 by e to the power of 5 plus e to the power of 11, that is e to the power of 11 plus e to the power of 6 plus e to the power of 3. This is the answer. Okay, so don't look at the complicated function that it is so complicated. So don't look at that. You need to find out which form it is. This is f of x to the power of g of x. So you need to use log for the differentiation. That's it. You will get your answer. Okay, next. Let g of x equal to f of x plus f of 1 minus x, and f double dash x is greater than 0. X belongs to 0 to 1. If g is decreasing in 0 comma alpha and increasing in alpha comma 1, then what is the value of this expression, tan inverse of this whole expression? Okay, so this is an interesting question actually, to understand one concept, simple concept. And this is my g of x. I can go ahead and do g dash x to find out f dash x, correct? Okay, now this is my f dash x, and we know that f double dash x is greater than 0, which means f of x is increasing. Okay, but is it useful for you? Is it helpful for you in any way? Okay, so look at that. This is given f dash x is increasing function. So okay, this is increasing, so this will be reducing, correct? So you need to understand one fundamental idea of functions actually. If g of x is in this form, f of x plus f of 2a minus x, okay, this is always symmetric about x equal to a. Okay, which means it will be like a sinusoidal function or any symmetric function around a. If a is here, whatever way if it is increasing here, it will be decreasing here. If it is straight here, it will be straight here. If it is decreasing here, it will be increasing here. Okay, this is symmetric about x equal to a. Now look at our given function g of x also in this form, f of x plus f of 1 minus x, which means this is symmetric about 1 by 2, correct? This is also always symmetric about x equal to 1 by 2, which means, okay, which means a symmetric function increases up to this point and then decreases, correct? So g of x is increasing in 0 to half and decreasing in half to 1, correct? Once you know this one, this is my alpha. My alpha is nothing but half, correct? If my alpha is half, tan inverse of 2 alpha plus tan inverse of 1 by alpha plus tan inverse of alpha plus 1 by alpha is nothing but tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3. Okay, now you can easily sum up these two. Okay, these two are nothing but tan inverse of 1 plus 2 by 1 minus 1 into 3 plus tan inverse of 3. Okay, you can, if you remember this value, you can do it. That is also one way. Okay, otherwise you try it this way. This is nothing but tan inverse of minus 3, correct? Tan inverse of minus 3 is nothing but pi minus tan inverse of 3, correct? So pi minus tan inverse of 3 plus tan inverse of 3, which means it is pi. This is the answer. Okay. So hope you understand this one. This is the important formula to be noted here. Okay, that's why I kept it in blue color. You may get different problems based on this principle. Okay. Next. Okay. Let the set of all positive values of lambda for which the point of local minimum of the function 1 plus x into lambda square minus x square satisfies this expression. Okay. Okay. If this lambda is in alpha comma beta, then what is the value of alpha square plus beta square? Okay. So first thing is this is my domain. Correct. This function is satisfying this condition. So let's first analyze the condition first. This is the condition. Okay, this is nothing but x square plus x plus 2 is always positive because its determinant is 0, so it will never cross x-axis, which means either it is above or below the x-axis, correct? So if I substitute 1, x square equal to 1, I know that this is always positive value, so this is always positive. Okay, so this won't influence anyway in my x domain, correct? So my domain is influenced by x 1 by x plus 2 into x plus 3. Now we can use wavy curve method easily, and we can find out x is between minus 3 and minus 2. Okay, x is between minus 3 and minus 2, which means x is in the bracket, I mean open bracket, minus 3 comma minus 2 close bracket. Okay, so this is where it is. Now I know my x domain. Okay, x is belong to this one. Now let's solve this lambda value. Okay, what could be the lambda? This is my f of x. Okay, if I expand it, this is what is 1 plus lambda square x minus x cube. F dash x is nothing but lambda square minus 3x square, which I should equate it to 0 to find the local minimum. Correct. So if I simplify this one, then I get x equal to plus or minus lambda by square root of 3, or other way, lambda equal to plus or minus square root of 3x. Okay. Now, if you take the x range, x is only negative value, correct? Which means if lambda is given as positive values of lambda, so which means I should take x, this only negative square root of 3x is the only possible value for lambda, correct? So lambda equal to minus square root of 3x, so that in the x range which is negative value, lambda will become positive. Okay. Now lambda is around minus square root of 3 and minus 3 to minus 2 is my x range. So which means it is between 3 square root of 3 comma 2 square root of 3. This is my alpha comma beta. That's what is given. Now once I know this one, alpha square plus beta square is nothing but 27 plus 12, which is 39. That's the answer. Okay. Hope you understand this one. Okay. Yeah. It's another interesting problem. Okay. Read the question. Let a rectangle ABCD of sides 2 and 4 be inscribed in another rectangle PQRS such that the vertices of rectangle ABCD lie on the sides of rectangle PQRS. let A and B the sides of the rectangle PQRS when its area is maximum. Then what is A plus B whole square? Okay. So what is trying to tell is this is A, this is B. Okay. And there is a rectangle ABCD inside the rectangle where ABCD lies on the sides of the original rectangle. That is PQRS. Okay. Now, his question is for this rectangle area to be maximum PQRS, okay, such that the rectangle ABCD lie on the sides, okay, and a rectangle PQRS when its area is maximum. This is the maximum area, okay, and but these values are given already. ABCD rectangle sides are given 2 and 2, uh, opposite sides are 2. This is 4, okay. Width is 2, length is 4. Now, with this, okay, what could be the maximum area of PQRS? Okay, when you look at it, we normally, whenever we see maximum minimum, we normally look at applications of derivative to find. But just I choose this problem here. This is nothing to do with applications of derivations. You can solve it very easily. Okay, so now let's say this angle is theta. Okay, now this angle is theta. We know that this is 90. Okay, so what will be this angle? 90 minus theta. Correct? This is 90 minus theta. So if this is 90 minus theta, this is also theta. This is also theta. Same way, theta. Correct? Now, my RQ equal to PS equal to A. RQ equal to PS equal to A. PQ equal to PQ. RS is B. Then AB should be maximum. That's the question. Correct? In triangle APD, okay, APD, PD is nothing but cos 4 cos theta. Correct? PD is 4 cos theta. If PD is 4 cos theta, similarly DS is nothing but 2 sin theta. Correct? Theta is here, so this will be 2 sin theta in this triangle. Okay. So now my PS is nothing but PD plus DS, which means it is A 4 cos theta plus 2 sin theta. This is my PS. Similarly, CS I can find out, RC I can find out, CS, RC I can find out. RS is nothing but B, which is 2 cos theta plus 4 sin theta. Okay. Now I have my A, I have my B. Okay. Now area of PQRS is nothing but product of these two. Okay. Which is nothing but if I expand, it will become 8 cos square theta plus 20 sin theta cos theta plus 8 sin square theta, which is nothing but 8 plus 10 2 sin theta cos theta is equal to sin 2 theta. So 10 sin 2 theta. Okay. Now this is my one. So I can apply differentiation and find out which is what is the maximum value. So I mean, what is the maximum I can get so that theta value I can take, but you don't require actually. Okay, this is a very, very simple expression 8 plus 10 sin theta. Okay, this will be maximum if sin theta equal to 1 because sin always ranges from -1 to 1. So maximum of sin theta is alpha is basically 1. So sin 2 theta also should be equal to 1. This is the when it is 1, then you get the maximum area, which is nothing but 18. Okay. Now, so if sin 2 theta equal to 1, that means 2 theta is pi by 2, 90 degrees, or theta is 45 degrees. If theta is 45 degrees, this is my A, correct? 4 cos theta plus 2 sin theta, which is 6 by 2 root 2, and B is also this one. This is my A and B I got. So A plus B whole square is nothing but 12 by square root of 2 whole square, which is 72. This is the answer. Okay. So hope you understand this problem. I choose this one because you are in applications of differentiation mode and you should know that there are other easy methods to find out maximum values, right? Number theory you should be good at. Okay. So this is a simple example of that problem. Okay. Yeah. Yeah, that's all. These are the problems I choose for applications of differentiation. Okay, you can actually make lots of varieties of questions in applications of differentiation. All you need is solution is quite simple actually. You will do 1 or 2 times differentiation, and then just apply simple number theory or equation rules. Okay, so keep doing more problems. I'll come up with more such problems. Okay, thank you.